Welcome to the class 16 of the Python course. In the last class, we studied the match cases. I taught you how to create a match case and where we can use them and showed you some examples as well. In today's class, we'll be studying a very important topic that's called OOPS or object-oriented programming and classes. So what is object-oriented programming? Object-oriented programming is one of the most effective approaches to write software. In object-oriented programming, you write classes that represent real-world things and situations, and you create objects based on those classes. So whenever we have to solve real-world problems, we use classes such that if we want a robot to get up and walk, then we can implement that by using the Python code, using classes and object-oriented programming. When you write a class, you define the general behavior that a whole category of objects can have, and you can then give each object whatever unique traits you desire. So we will create a dog class that will also include the method to sit and roll over. So this is what making an object from a class is called instantiation, and you work with instances of a class. In this chapter, you will write classes and create instances of those classes. So we will write a class, and class will include the instructions on how to create an instance, such that we will create a dog by its age, name, and it has the ability to sit and roll over. These are all the instructions to create an instance that I'll show you in a minute. Knowing the logic behind classes will train you to think logically, so you can write programs that effectively address almost any problems you encounter. So this is the benefit of the classes. Classes also make life easier for you and other programs. You'll need to work with as you take on increasingly complex challenges. So classes also help us to collaborate with our programmers, and we can do complex tasks. So let's create our first class. You can model almost anything using classes. Let's start by writing a simple class dog. So what the class dog will have, the dog class will store a name and age and the ability to sit and roll over. So class dog, first thing is starting it, the class. This is how we start. Then we have the init function, and whatever function is inside a class, we call it the method. So we have an init method that does most of the work, and then we will have extra abilities, and we also call them methods. So we have extra methods that we want to include in our class. So if you look on the left on my VS Code window, first of all, let's start creating a class. So we start by typing class. This is a built-in function, and naming it. I'm naming it dog and giving it and keeping the first letter to be capital. Now in the next line, we will define what this does. This is a simple attempt to model a dog, and next we will start use this function called the init. So whatever function we will create inside this class, 1 2 3 4 spaces, and now we are inside the class dog. Whatever function that it will include, that we will call it a method. So define underscore init double underscore. So we have two pre-variing underscores and two trailing underscores. What this does, that if we create a method or a function in the future that has name init, it will not cause a conflict because init is built in the Python, and even if we try to build init in our code later on, this double underscores will prevent. And the next thing is the self parameter. So the self parameter will help us gives access to the instances that we will create later. So whenever we create an instance, that instance will use self and make connection with the init method. And the next thing we are going to include is the name, the second parameter, and the age. So it depends upon what real problem you are trying to implement. So we are implementing a dog. So obviously we need an a name and age. Now in the next line, we will write that what we are going to do. We are creating, or I should say initialize name and age attribute. And now I will create attribute. How? I will use self dot name. So this parameter will take this value, store it into a variable, and we will create the variable with the same name, call it the name. So whenever the instance that we will create will call the name or age, this self parameter will help us to get the name, and similarly this self parameter will help us to create age that we have stored in this variable with a similar name. So this is a variable and this is a variable, and we did this using self parameter. And the next thing we have is define sit self. So now we are creating another method that is the sit. Again here the self allows access to the instance that we will create later on. Now we will explain what this does. It stimulates a dog sitting in response to a command. And this, now we are just going to simply print that the dog is sitting. If we have the resources like a dog that is animated, we will write the code that the animated dog will sit and do the rollover. And that code should be here, where I'm going to write the print state self.name.title. So again, I took this variable and then I simply print is now sitting. And in a similar way, we'll create the second method that will be define roll underscore over self. And the same way I will explain what this does. This simulates a rolling over dog. Print self.name.title plus rolled over. So similarly, like sit, I printed the statement for the rollover. And again, if we had an animated dog, we can make by writing extra lines of code inside these methods, that is a rollover and the sit. So now we have this class, right? We started by typing class and we gave it a name with the first letter capital. Then we used our init method. It's a function. Because it's inside a class, we will call it a method. So we use init method, and inside the init method, the important thing is this self parameter. That self parameter will be connected to instance that we will create using this class, because we can make use of the class only using the instances. And then we have a second parameter. This is going to be according to the problem we have. So now we are attempting to model a dog, so that's why we have a name of the dog and age of the. Similarly, we can have the arms of a robot or the eyes of a robot. Eyes means a camera of the robot. So that thing is going to replace the name and age with the, you can say, arms or camera. And the next thing we are storing these parameters into the variable self.name self.age, because this is going to be used for the instances that we will create just now. And again, we have the extra ability, that is to sit and to roll over. Right now we just printed the statement that the dog is sitting and the rolling over. But if we have the resources, or we want to really move a robot dog or an animated dog, we can do so by replacing or adding the more lines of code here. So now let's make use of this class by making an instance. So in order to make an instance, what we are going to do, we'll simply use my underscore dog. I named my instance my dog because it's related to the dog. You can name it whatever you want to. And now we will call our class dog and pass the parameters, that is Willie, that is the name of the dog, and it's 6 years old. Remember, we did not use self here. We only gave two parameters. The name and age of the dog. And then I'm also printing some statements such as my dog's name is plus my underscore dog dot name dot title plus. So I'm also printing the name of my dog which I gave it, and again I will also print the age of the dog in a similar manner. So I'm just copying this statement, pasting it, and just replace my dog is, and here with the name I will use the age. I will convert it into a string because it's in integers. String my underscore dog dot age, and it's years old. So this is a string. This is the value that we have given, and this is again a string. So string value and converted into string, because we did the concatenation here. This is called concatenation. Now I've run the program. Here it says my dog's name is Willie and my dog is 6 years old. Here you can see my dog's name is Willie and my dog is 6. So this is an instance, and in order to create this instance, we have these instructions. We created class. We used the init method, we gave it parameters including self, then we added it an extra ability, and then again an extra ability. So this is how you create instance by creating a class. So this is how we have implemented a real world problem using object oriented programming. Now let's talk about this concept of accessing the attributes. If you see here, we used my underscore dot notation and then name to access the name variable, and same for the age, my underscore dog dot age. So in this way you can access the attributes for an instance. We accessed name and age for our instance called my underscore dog. So to access the attributes of an instance, you use the dot rotation as I just told you. Here Python looks at instance my underscore dog and then finds the attribute name associated with my underscore dog. So our instance has these attributes self.name, self.age, and then these are used by our instance using the dot notation. And we have after running the age and the name that we give. So this is how we access the attributes of a class. Now let's move on to the next concept, that is calling methods. So we haven't called the extra methods that we created, the abilities to sit and to roll. In order to do that, all we have to do, we type my underscore dog, we will use our instance, and the same way we call the attributes, we call the methods. We've called the first method my underscore dog sit, and the similar way we will call my underscore dot roll underscore over. And here I forgot to mention the dog, and here we have. Now if I run my program, you will see it is giving us the dog's name. My dog's name is Willie. Second, my dog is 6 years old, and Willie is now sitting. And here if I add the parenthesis, it will give us Willie rolled over. There is no space here. Let me add the space here and here. Now if I run the program, here you can see Willie is sitting now and Willie rolled over. What happened was when Python reads my underscore dog dot sit, it looks for the method sit in the class dog. You see here there's a capital D and runs that code. Python interprets the line my underscore dot roll over in the same way. So the similar way it accesses the attributes, we can access the method. And here you can see. So we learn to access attributes, we learn to access the method, and now there is another concept that we can create multiple instances. So we created an instance, my dog, and we gave it the name, age, and then we printed two statements of course the name, age, and then we also made it to sit and roll over. In the similar way, we can create another instance. So in order to do that, I will change the name. I will say your dog equal to, I will call my class dog that I created and name it like Lucy and giving it the age 3. And in this way, I will repeat the steps that I did earlier. I will print the statement, your dog's name. I created a string and then I will call the attribute that I have created, and that is going to be, so the code is going to be your underscore dog dot name dot title and parentheses, and at the end I'm going to write again a string called is now sitting. All right, and in the similar way I'm going to print the age. So I'll just simply take from here and paste, and instead of my I will type here your, and instead of my underscore dog, I will replace it with your underscore. And I can also call the methods here. I will simply replace my dog with your dog. And same here, my dog with your dog dot roll over. Now if I run the program, oops, we got an error. What's the error? This is the error. So make mistakes and fix them. This is how you will learn. And now if I run it, we have both of your dog's name Lucy is not sitting. Your dog is 3 years old. Lucy is now sitting. Lucy rolled over. Alright, so let me see what happened. Your dog's name is not sitting, and your dog's name is Lucy and is not sitting. Alright, so I added this /n. This will separate this instance from this one. And now if I run the code, you will see we have the input of both the instances. My dog's name is Willie. Your dog's name is Lucy. My dog is 6 years old. Your dog is 3 years old. Willie is now sitting. Lucy is now sitting. Willie rolled over. Lucy rolled over. And in this way, you can make multiple instances in object-oriented programming. And here there was space here because I placed a space here, so it was showing up, so I removed it. So here are the things we should know. Each dog is a separate instance with its own set of attributes capable of the same set of instructions. Even if we use the same name and age for the second dog, Python would still create a separate instance from the dog class. Why? Because we have used different name of the instance. So that's why even if we had given it Willie and age is 6, then it was still going to give us an extra instance because we used a different instance name, that is your dog. The next thing is you can make as many instances from the one class as you need, as long as you give each instance a unique variable name or it occupies a unique spot in a list or dictionary. So as the thing I mentioned, if you have a unique name of the instance, you can create as multiple instance as you want, even if the parameters such as the name, age, or have the same value. Now let's move on to the next concept, that is about working with classes and instances. So what this is about is that one of the first tasks you will want to do is modify the attributes associated with a particular instance. You can modify the attributes of an instance directly or write methods that update the attributes in specific ways. Obviously, if we have to upgrade something and we want something new in our new instance, we have to change or modify the attributes. So in this concept, we will learn how to do that. Okay, for that we are creating a new class, that is the car class. In this, let's write a new class representing a car. Our class will store information about the kind of a car we are working with, and it will have a method that summarizes this information. So again, similarly, first of all, we will have a class. This is how we're going to start. We're going to start the built-in function class. Then we're going to name our class as car with its first letter capital. Inside the body, first line we're going to write that will tell us what is this class about. It is a class that represents a car. The next thing is obviously our init function, or as I told you that inside a class a function is called a method. So we will use init method. Two underscores are leading and two are trailing. And now we will add the first parameter, that is going to be self, the second parameter make, then model, and then year. Now in the next one, we have initialize attributes to describe. So now we have created our init method, and next thing is to create our attributes. So obviously the first one is going to be about the make, and we will store it in a make variable, self make. Secondly, model, we will store it into the self model, self dot model is equal to model, and then we are going to do same for the self dot year equal to year. That's how we have created three variables. Now what we are going to do, we are going to create another method that will describe what these attributes do while summarizing them. So we will start with define get underscore descriptive underscore name parenthesis self. Remember to we pass this self parameter so that whenever we use this in our new instance, it gets connected to that with the help of self. Inside the body, we will first of all tell what this method does. It returns a neatly formatted descriptive name. Then we will create a variable long underscore name and make it equal to the value. We are going to make it a string because years are always in numbers. Similarly, we will print other values that include make and self model. Self make. Alright, so now we have a method that describes in a neatly format, and now we will return what it describes, long underscore name dot title. So we have created our class. Class includes our init method that has three parameters, make, model, and year. And now we have another method. What this does, it returns a neatly formatted descriptive name. So we have a long name variable that includes and prints the values of year, make, and model. And we do this by returning the value of this variable and using a method called dot title and parenthesis. This will print the value of this variable, which is giving us a neatly formatted descriptive name. Now we will create our first instance, that is my new car is equal to. Now we will call our class, and now we will pass our parameters. First of all is Audi, then A4 is the model, and the year is 2016. Next thing we are going to print is obviously the class values. My new car dot get underscore descriptive name parentheses. That's all. Now if I run my program, here it says 2016 Audi A4. Now here is our class and here is our instance, and our program is running fine. And again, I'm going to repeat what we have done. We created a class the init method that I told you that is going to be included in all the classes. In these concepts, which I'm teaching you, the first parameter is going to be self, like the previous one. Then the three more parameters for the car class. Then we are storing these in a variable, giving us attributes 1, 2, 3. Three variables, three making us or giving us three attributes. And next we have another method. What this method does is that it gives us neatly formatted descriptive name. It includes the year, the make or the type of the car, and the model, and then we are returning the value. So this is our class or the instructions to make an instance. And here we make our first instance. In the instance, we have my underscore new car, and you can name it whatever you want. I named it according to the book. My underscore name, my new car ODA for 2016. And then we have printed this method right here. That gives us the neatly formatted year, car type or make, and model number. We'll run it again, hit give. So, all right. So the main motive of this concept is to see how we can change very attributes and for different instances. So we have created a new class. Now we will learn the next concept, that is setting our default value for an attribute. All right. So first of all, we're going to take this class, paste it here. Now we have, and I'm going to command this out. All right. So what we are going to do, every attribute in a class needs an initial value, even if that value is 0 or empty string. Okay. Let's add an attribute called odometer that always start with a value of 0. We will also add a method read underscore odometer that helps us read each car's odometer. So simply add here self dot odometer underscore reading and set its value to 0. See, when we are setting the value to default, we are not defining that parameter here. And after this method, we are going to introduce another method that is going to be define read underscore odometer self, and then we are going to describe what it does. It prints a statement showing car mileage. Now we are going to use our print function. This car has string self dot odometer reading plus miles on it. So we are just simply reading the value of this attribute that we created, and on the other side are just simply the strings. And we also converting the integer value of the odometer to a string so that we can print the value. And now what we also have a new method called read odometer that makes it easy to read car's mileage. Yes, so we created a new method that reads car's mileage, and we introduced a variable, and we introduced the attribute with the default value 0. So now if I simply use my instance, my new for car, and then read the odometer, and I run the program, 2016 Audi A4. This car has 0 miles on it. You see there is no space. The reason is I did not add here. So now it should have some space. All right. So this car has 0 miles on it. So this is how we can introduce attributes with default values, and we can read, and now we are able to read the mileage on a car. So you see, the more things are getting realistic, the more we are being able to add to the class, and we are implementing real world things. So again, we created our class, we introduced a new attribute, we introduced a new method, and then we simply called it. So this was the concept of setting a default value for an attribute. Now let's move on to the next concept, that is modifying attributes values. So how can we do that? First of all, let me comment this out. You can change an attribute's values in three ways. You can change the value directly through an instance, or secondly, set the value through a method, or third, increment the value at a certain amount. Let's see the first one. Modifying an attribute's value direct. The simplest way to modify the value of an attribute is to access the attribute directly through an instance. Here we set the odometer reading to 23. All right. So let us take our code from the previous program, and we will take our instance my new car and change our odometer's value to 23, and then we will use our instance and call this method, which is to read the odometer. Now if I run the program, you will see we have directly modified the value of our attribute that was set to 0. We modify it to 23. So this is how you can directly modify the value of an attribute. Now let's move on to the next concept, that is about modifying an attribute's value through a method. So this is how we can do it. So I'm going to copy this, place this here. All right. So we have our class and our previous instances. Now we are going to create a method. So we will define update underscore odometer and then give it the first parameter as self and the second one as mileage. And then we are going to tell that what this does. This sets the odometer reading to a given value. And then we're simply going to create a variable that stores the mile. Odometer reading equal to mile. Now we can modify the value of the attribute using this method. How? We are now going to call this method by using our instance my underscore new underscore call dot notation, and then we are going to call the method update odometer to 23, and then my underscore new car read the odometer. So we are calling this method and we are calling the new method that helps us to modify the value of an attribute. Now if I run the program, it says year, make, and model number, and it also modifies the value of the attribute. What is that attribute? The attribute is the odometer. So previously we were modifying the value directly, and now we are using this method which we have defined as update underscore odometer. All right, so there's another concept. We can add a little logic to make sure no one tries to roll back the odometer reading. So how we can do this? We can do this by coming here and using our if condition statement, that if our mileage is greater than or equal to self dot odometer underscore reading, then we are going to set up condition that our odometer reading is going to be equal to the mileage. But if that's not the case, then you have to print that we cannot roll back an odometer. Alright guys, so I made a mistake here. That is, we need to remove this line, and then if I supposed to be alright, so now if I change this value to 15, it's still running. But if I change to minus something like 5, it says you can't roll back an odometer. This car has 0 miles on it. So this is our value that has been set to default. But if I change the value to like 25 and then run it, here it says this car has 25 miles. So this is how you can modify the value of an attribute using a method, and inside that method you can implement an if else condition statement. Now let's move on to the third concept of how you can modify an attribute, and that is incrementing an attribute's value through a method. Here is a method that allows us to pass this incremental amount and add that value to odometer's reading. So I'm going to use this code, place it here, and then use this. The next concept is incrementing an attribute's value through a method. Alright, for this concept, what we are going to do is we're going to add another method. Here is a method that allows us to pass the incremental amount and add that value to the odometer reading. So we need to create another method. This is how we can do this. We're going to define increment underscore odometer. As always, we'll pass self miles. Then we will define what this does. It gives amount to odometer, and then we will write the code for the incremental operation. Self dot odometer underscore reading is equal to, sorry, this plus sign will do the increment mile. So this will add value to the miles. So this plus sign will increment the value. And now we are going to create another instance that will be my underscore used underscore car. Let me just command this my underscore used underscore car equal to car, and we called it Subaru, and then Outback, and then the year. That is going to be 2023. Let me just see what happens with the double click. Now we're going to print the my used underscore car dot get underscore descriptive name. Now we're going to print the value, which are going to be these. And the next thing we will do is to call the update odometer value in our new instance. My used underscore car dot update odometer, and then we put 23,500. Now we will my car read odometer. There we have the odometer value of our used car. So here is our first instance that gives us the details of our used car, and here is the second instance that gives us the odometer value of our used car. And now we are going to create another instance, and that instance will use the increment method that we just created. So for this concept, that is how to modify an attribute using incremental method. So now we are calling that incremental method. Increment odometer, and we'll give it 100 value. And now we have my underscore used dot read odometer, and here we go. Now if I run the program, here you will see, first of all we have the details of our car, and then we have the used car mile, then we have the new one. So our program is working perfectly fine. Now there is another thing which the book has mentioned, is that you can easily modify this method to reject negative increments, so no one uses this function to roll back an odometer. In order to do that, we'll have to add the condition here. And we can do this by using our if else condition. So if miles are greater than equal to read, let me see what we named our odometer attribute. So it's miles odometer underscore reading self dot underscore. Then what this is going to do, this will, yes, so this will increment the value. Else we will print you cannot add negative value. So here our program is running, and we need to make a minor tweak here. Instead of using self dot odometer reading, we are supposed to use 0 here. So if I'm using 100, it should work perfectly fine. 2023 Subaru Outback, this car has 23,500 miles on it, and when I incremented the value by 100, it says 23,600. But what if I give it minus 100? It should execute the statement you cannot add negative value, and here it says this car has 23,500 miles on it, you cannot add negative value. This car has the same value, that is 23,500 miles on it. And the next the book says you can use methods like this to control how users of your program update values, such as an odometer reading. But anyone with access to the program can set the odometer reading to any value by accessing the attribute directly. Effective security takes extreme attention to detail in addition to basic checks like these shown here. So we added simply the if else condition, and this has improved our program a lot. So these were the three methods of modifying attributes value: by changing directly through an instance, or secondly by setting the value through a method, or thirdly incrementing the value through a method. So these are the three ways by which we can. And now let's move on to the next important concept, that is the inheritance. Alright, so now let's talk about the concept of inheritance. So in inheritance, we used old classes in our new class that is called the child class, and we can also include new things into our child class. The parent class is the old classes that we have first created. So let's read this, that will make the things clear. If the class you're writing is a specialized version of another class you wrote, you can use inheritance. When one class inherits from another, it automatically takes on all the attributes and methods of the first class. The original class is called parent class, and the new class is called child class. The child class is also free to define new attributes and methods of its own. So as I explained you earlier, old class is called parent class, and the new class is called the child class, and the new class also has the ability for new attributes. Alright, so for this, the init method for a child class, this is how the first thing Python has when creating an instance from the child class is to assign values to all attributes in the parent class. To do this, the init method for a child class needs help from its parent class. So in order to move attributes from a old class to the new class, we are going to do this. An example, let's model an electric car. An electric car is just a specific kind of car. So we can base our new electric car class on the car class we wrote earlier. Then we will only have to write code for the attributes and behavior specific to electric cars. Let's write by making a simple version of the electric car class which does everything the car class does. So let me just copy the car class that we have created earlier. So we have our old class that was the car class where we will call it the parent class. And the next thing we are going to do is we are going to create our child class. So let's do this by starting with the same way. We will write class and then name it electric car, and inside the parentheses we will call our parent class that is going to be the car. And now we will resume the activities like the earlier. So as we did earlier in the second line, we define that what this new class does. It represents aspects of a car. And now we'll define a method 1, 2, 3, 4. Define init method. And in the same way, we'll pass the parameters like we did in our old class. Make, model, year, and so on. And now we will define that we are initializing the attributes of the parent class. So we are now moving the attributes of our parent class to our new class by using this function called the super dot leading underscores init, and inside make year, make model, and year. So the super function is a special function that helps Python make connection between the parent and the child class. And just like the init method or init function, we're not supposed to do that. Right, the next thing we will do is we'll create our instance and storing it in whatever electric car company you like. So I'm using Tesla, just as the book did. Electric car, and here are the parameters of our instance. Tesla model 2016. So here we have created our instance and then stored it into a variable named as my Tesla. And the next thing we're going to do, we're going to print the values. Print my underscore Tesla dot get description name parentheses, and that's it. Now we are set. Now we are all set. We used our old class with all these methods that we defined in the previous classes I taught you, and then we simply created a new child class. We then inherited the attributes of the parent class and simply created a new instance. Now look at the number of lines of code. Here is a lots of lines, but here there are only 5 lines. So now if I run it, here it says 2016 Tesla, and this is how you can inherit the attributes of the class that you have already created into a new class and add something new to it as well. Alright, so now let's move on to the next concept, that is defining attributes and methods for the child class. So by now we are only using the attributes of our old class. In this concept, we will be using and defining new attributes for our class. Defining attributes and methods for the child class. You can add any new attributes and methods necessary to differentiate the child class from the parent class. Let's add an attribute that's specific to the electric cars, a battery, for example. So we will add an attribute named as battery to our child class. So in order to do that, I'll just copy this and paste here, and then I'm going to create my attribute in the new child class. So we will use self dot battery underscore size and setting it equal to 70, just like we did with the odometer in the last concept I taught you. And we will also create a method for this battery. Describe underscore battery self print a statement describing the battery size. So this will simply print a statement about the size of the battery. So in order to do that, we'll simply type print, then start a string. This car has a string self dot battery underscore size. Then we're going to, alright, so we created a attribute and we also created the method that prints the value of this attribute. And so now I'll just simply call this method. And I will run it. It says this car has 70 kilowatt battery, 70 kilowatt hour battery. So this is how you can define attributes and methods for a child class. Now let's move on to the next concept, that is overriding methods from the parent class. For example, if we have a method, let's say fill gas tank, all right. To do this, you define a method in the child class with the same name as the method you want to override in the parent class. Say the class car had a method called fill underscore gas underscore tank. And here is how we can do this. So we will define car, define electric car, and inside the body we will have all the code that we created, and then this is how we simply override the method that was already present in the parent class. So we can do this by naming it the same name, gas underscore tank and parentheses. Now if I see in our old car class, we had a method named define read underscore odometer, or define, okay, let me just remove this. And so we have this method, right? So we had this method, right? Define odometer, define update odometer. Similarly, if we had a method named define fill gas tank in the car classes right here, then and we want to override it, then we can simply do this by naming it with the exact same line, with the exact same name. And let's see that electric cars don't have gas tanks. Print this car doesn't need a gas tank. So again, if we had a method in the old class, that is our car class, the simple class call, and we want to override it, then we can do this, and we want to override it in our new class, then we can simply do this by creating the method with the exact same name, and this will override the method already present. So if we have increment odometer, right? And we can do this by typing increment underscore odometer and then self and miles, and we can add something extra. So this is how we can, and remember that this is the old class with the old method inside. And if we want to add, and if we want to override this method in our new class, we can do this by simply initializing a new method with the same name in the child class. This will override the value of this method in the old. So I hope that you understand the concept. Python will ignore the method fill underscore gas underscore tank in the car, which is our parent class or the old class, and run this code instead, that is inside our new class or the child class. Right. So now let's move on to the next concept. That is, you will find that you are adding more and more detail to a class. For example, if we continue adding detail to the electric car class, that was our child class, we might notice that we are adding many attributes and methods specific to the car's battery. When you see this happening, we can stop and move these attributes and methods to a separate class called battery. Then we can use a battery instance as an attribute in the electric class. So we had our, let me just copy our both classes, the parent and the child one. So here is our class car and here is our child class. And now what we are going to do, we are going to create another class and we are going to call it battery. And then we are going to comment what this does. Simple model of a battery. And then we'll define underscore init self. Now we are passing the parameters and we are giving it default value 70. And inside we are going to create our attribute self dot battery underscore size equal to battery underscore. So now we have a new class with a new attribute, and now we're going to create a new method. Find describe underscore battery self, and inside this method we are simply printing a size describing statement. We will use print this car has a plus string self dot battery underscore size plus kilowatt hour battery. So now we have another class. Remember that this class does not inherit anything from our old class or the one I called the parent class. And we have, because we were adding more and more attributes to our electric car class or the child class, we created a new separate class and added attributes to it. Now we can use this into our electric car one. And this is how we can do this. This is how we can do this. Self dot battery equal to battery class. So we stored the battery class that we newly created into this variable self dot battery. And we can also, now if I replace this and comment this out, so this variable is being used here and we are just calling it at the end. Dot battery dot describe battery. And here if we see at the end when we are calling it, we are typing my underscore Tesla dot battery dot describe battery. And here we have the result. To run it, it says 2016 Tesla model. This car has a 70 kilowatt hour battery. So what we did, we instead of adding more and more attributes to our child class, we simply created another class named as battery, and we utilize this battery into our child class again. So now we have three classes: the parent one, an extra battery class that has no link with the parent, and finally the child class that has links with the both. So this line at the end, this one right here, this tells Python to create a new instance of battery with a default value of 70 because we are not specifying a value, and store that instance in the battery in the self.battery. This will happen every time the init method is called. Any electric car instance will now have a battery instance created automatically. Alright, now let's add another method to our battery. So as it was going to become longer and longer, we are now utilizing the battery class again. So in this, we are adding another method to battery that reports the range of the car based on the battery size. So we will simply define a method with the get range self and prints a statement about the range this battery provides. And inside where I'm using the conditions that if the battery size is 70, then you are going to print this range, that is 240. And if or else if the side of the battery is equal to 85, then range is equal to 270. But if the battery size is 70, it will print the range is 240. And if the battery size is 85 kilowatt per hour, then it's going to print the range 270. And then we will also print the messages. Message equal this car can go approximately the range. Message miles on a full charge. That is going to print the statement this car can go approximately the range, that it is either going to be 240 or 270, and then it's going to add that miles on a full charge. So 240 miles or 270 miles. First this statement will be executed, then this, either of these values, and then this statement. And then we are printing the message. And now at the end, we are calling my Tesla.battery.get range. That. So see, we have created this range method inside the class battery, and we are utilizing it inside the class electric car. How? Because we have stored our electric car instance inside my Tesla, and we are using my Tesla dot battery plus and dot get range method. Now if I run it, It says 2016 Tesla model. This car has a 70 kilowatt hour battery. This car can go approximately 240 miles on a full charge. Now, if I change the value from 70 to 85, and if I run it, it says this car can go approximately 270 miles on a full charge. So this is how we created a new class that was separated from the parent class. Then we added a new instance. Then we added a new battery. Then we added a new attribute, created a new instance, and then again we created a new method inside the battery class. We set up conditions, printed two message values, and then we called this method inside our electric car instance in the child class. So I hope you understand this concept as well, that we don't need to just keep on writing our code inside two classes. We can create multiple classes and then utilize them inside one. So here it says, as you begin to model more and more complicated items like electric cars, you will wrestle with the interesting question such as, is the range of an electric car a property of the battery or of the car? Or questions like, if we are only describing one car, it's possible to find to maintain the association of the method get underscore range with the battery class. But if we are describing a manufacturer's entire line of cars, we are probably want to move get range to electric car. And also this brings you to an interesting point in your growth as a programmer. When you wrestle with questions like these, we're thinking at a higher level, logical level than at a syntax focused level. You are thinking not about the Python, but about how to represent the real world in code. When you reach this point, you will realize that there are often no right or wrong approaches to modeling real-world situations. Some approaches are more efficient than others, but it takes practice and to find the most efficient representative. So that was all about the concept of the inheritance. In inheritance, we studied how we can use our old class and create a new class and use the attributes of the old class. The both classes are now called parent and child class. Then we studied the defining attributes and methods for a child class, because child class can have the old attributes and we can create new attributes as well. Then we studied how we can override methods from the parent class, and we can also use instances as attributes. In that, we created a new class that was separated from the previous two classes, previous parent and child class, and we then use this third class with our child class. And we also created new attributes and used that also into our child. And then we also learned the importance of real world objects and critical thinking, that how we can implement real world problems into our coding programs and solve them and help others. Now let's move on to the next concept, importing classes. So in this concept, we will learn that how we can place all of this code into another file, and then in a new file we can only use one line of code to use our classes. So this is how we can do it. First of all, as you add more and more functionality to your classes, your files can get long, and even when you use the inheritance properly. To help, Python lets you store classes in modules and then import the classes you need into your main program. So let's see how we can import a single class. Let's create a module containing just the car class. Alright, so if you see on my VS Code window, I'm going to create a module named car.py. And inside of this, I'm going to store my parent class, that is the car one. At the top, I'm going to type parent class module, and inside I'm going to place the whole code and then run it. Now this module, the car.py, has my class car, and if I go back, I have commented out, so this file has no idea what a car class is. Now if I type from car, that is this module, import car class, so we are now importing this car class, this whole code. This has been imported into our this module, that is the object oriented programming class. And now I'll use my underscore new underscore car equal to car, and then I'm going to pass the parameters OD for 2016, and then I'm going to print my underscore new dot get descriptive name, and there you go. And also I'm going to use the methods my underscore new car is again dot odometer equal to 23 my underscore reader. Now if you see this, there are a lot of lines of code, right? But here we are only left with 3 to 4 or 5 lines of code. Now if I run it, it's executing perfectly. 2016 ODA4 model. This car has 23 miles. So we have successfully imported a single class from another module. We first created a module, we placed our class inside and named it as car.py. Then we imported this module from car import car into this module, and then we utilized or performed operation using this class. Now the next concept is we can store multiple classes inside a module. Storing multiple classes in a module. And here you can store as many classes as you need in a single module, although each class in a module should be related somehow. So we know that our electric car, our glass battery, they are related to this class somehow. So I'm first of all going to uncomment this, copy these and paste them here. So we now have electric car class here, battery class here, and as well the car class here. And now again I'll import these classes from that module, from car module, by typing from car import electric car. Now have the access to the class electric car, right? And now I'm going to get the instance. My Tesla is equal to electric car Tesla model and 2016. The next thing is my underscore Tesla. Now I'm going to print it. Print my underscore Tesla dot get descriptive name. Now we are going to print this instance, and then we will also make use of the battery class. Battery get dot describe battery. The next one we have my underscore Tesla dot battery dot get range. Now if I run my program, oops, we got an error. Error is I didn't test this. What the error is? The error says, oops, we didn't run this code. Alright, now we're good to go. Make sure when you place the code for the new classes here, you run this file. Now inside I am calling the electric car class, and also I'm making use of the battery methods. Now if I run it, again giving the error. Alright, so it's running fine. This car can go approximately 270 miles on a full charge. This car has a 85 kilowatt hour battery, 2016 Tesla model. So we have now imported multiple classes and also made our program to run. So this is how you can make use of multiple classes inside a module. As we have stored multiple classes on a module, in this way we can import the multiple classes into our module as well. You can import as many classes as you need into a program. If we want to make a regular car and an electric car in the same file, we need to import both classes, car and electric car. So for this we are importing both the classes. First of all, I will write car, import the car class and the electric car class, right? Then I'm going to create my first instance, my Beetle equal car into Volkswagen Beetle 2016. And then I'm going to print this instance that I just created. Now I will create another instance for using my second class, that is the electric car. Now I'll make use, and now I'll use my now I'll use my second class, that is the electric car, and type my underscore and create a new instance. My underscore Tesla equal to electric car Tesla Roadster 2016, and this should be a string. This can be a number. Alright, now I'm going to print this as well. Print my underscore Tesla dot get underscore descriptive underscore name, and that's it. Electric car. I think I named it right. So this is supposed to be this electric car here and electric car. Alright, I think we're good to go. We have imported two classes now, and we created two different instances from two different classes. Now if I run it, it says Volkswagen Beetle and 2016 Tesla Roadster. So two different instances from two different classes. That is how the concept of importing multiple classes from a module can be understood. Alright, the next concept is importing an entire module. Alright, so let's place it here and name it importing entire module. You can also import an entire module and then access the classes you need using dot notation. This approach is simple and results in code that is easy to read, because every call that creates an instance of a class includes the module name. You won't have naming conflicts with any names used in the current class. So we'll simply type import car and we have all the classes present here. The electric car class, battery class, and the parent class, that is the car one. By simply typing import car, we imported all of those classes. And now again, I'll just, if I copy this code and paste it here and I run it, it should work perfectly fine. Import car. But the thing what you are going to do is you are going to include the name of the module and add the dot notation. So car dot this whole. And same for this one. We are going to include the name of the module car and add the dot notation. So this is how we can import the entire module and then access the individual class. Run it, running completely fine. 2016 Volkswagen Beetle, 2016 Tesla Roadster. Now let's move on to the next concept, that is importing all classes from a module. Importing all classes from a module. You can import every class from a module using the following syntax. From module name static. So if I type from car import static. So now I will be able to import all of these classes by simply typing from car import all the classes inside. But this method is not recommended for two reasons. The first thing is if you accidentally import a class with the same name as something else in your program file, you can create errors that are hard to diagnose. And if you need to import many classes from a module, you are better off importing the entire module and using the module name.class name syntax, which is the last concept that we just discussed. And the second thing is you won't see all the classes used at the top of the file, but you will see clearly where the module is used in the program. We'll also avoid the potential naming conflicts that can arise when you import every class in a module. So instead of importing all classes from a module using this statement, it's better to import an entire module and then using the dot notation, we access those classes. Now let's move on to the next concept, that is importing module into a module. Let me command this out. Importing module into a module. Sometimes you'll want to spread out your classes over several modules to keep any one file from going too large and avoid storing unrelated classes in the same module. When you store your classes in several modules, you may find that a class in one module depends on a class in another module. When this happens, you can import the required class into the first module. So for example, let's store the car class in one module and the electric car and battery car in a separate module. So we have car class. Now I'll simply remove my electric car class from here and the battery class. Now the car module only has my car class. Now let me create another module that will have electric underscore car underscore detail dot py, or I can simply name it shortly to electric underscore car. And here I can paste my other two classes, that is the class electric car and the class the battery. If I run this and run this, both of these have been stored. And now I can show you that how we can import a module into module. So first of all, I will from car import car. Now we have access to the first class. All right. And now we can access the electric underscore car import electric car. All right. So from one module, I imported the car class, and from another module, I imported electric. And we have our first module, my underscore beetle equal to car, and obviously I'm going to create these two instances that I have already created. I'm just simply going to copy them and paste them here again. So if I run my program, I need to remove these two because I am not importing a module now. I am importing modules and then classes from them. So if I think I mixed this statement. Just need to remove the dot notation and just make use of the module into a module. Now if I run it, one more thing we need to update is that we need to write this statement from car import car. We are importing this module into our class battery and class cars, and then we have these two, the class module separate, the battery and electric car module is separate. These two are separate, and then we have inside we imported the car module and then electric car module that has also the battery in. I will run it. It's running completely fine. We have 2016 Volkswagen 2016 test. Now we are working with three different modules. Module 1 parent class, module 2 with the child class, and a module 3 where we are importing both modules into this module. Here it says at one we import car from its module and electric car from its. Here it's reduced to 2 lines of code from other classes where there is huge amount of. And now here is a great advice from the author of the book. As you can see, Python gives you many options for how to structure code in a large project. It's important to know all the possibilities so you can determine the best way to organize your projects as well as understand other people's projects. When you are starting out, keep your code structure simple. Try doing everything in one file and moving your classes to separate points. Once everything is working, if you like how modules and files interact, try sorting your classes in modules when you start a project. Find an approach that lets you write code that works and go from. That's it about the importing class. And that's it about the concept of importing. Now let's move on to the final topic about the object-oriented programming, that is the Python standard library. The Python standard library is a set of modules included with every Python installation that we will be using in the future while installing. We import those modules and use in our project. Here is an example where we are importing a dictionary and we are importing a module that is of ordered dictionary. What this allows us to take two benefits. This is a great class to be aware of because it combines the main benefits of lists, retaining your original order, with the main feature of dictionaries, connecting pieces of information. So we imported this ordered dictionary class, we stored it in the favorite languages, and then we have this dictionary, right? By using this class, we have ordered dictionary at the end. So this is the benefits of the class, because usually when we use dictionary, they are not ordered, and in list we don't have the details. So it combines the benefits of both. We have the order from lists and details from dictionary, and the both are combined. Next one, it says you can also download modules from external sources. You will see a number of these examples in our project in part 2 in projects where we will need external modules to complete each project. All right, for the people who made it to here, I'll start the project from the next class. There will be 5 projects at least. All right, styling classes. Classes name should be written in camel caps. To do this, capitalize the first letter of each word in the name and don't use the underscore. Instance and module names should be written in lowercase with the underscore between words. Every class should have a docstring immediately following the class definition. You can use blank lines to organize the code, but don't use them excessively. You can use one blank line between methods. And the next thing is, if you need to import module from standard library and a module that you wrote, try importing the standard module first. So these are some styling class, some instruction for styling the class. And here is a summary what we learned. In this chapter, you learned how to write your own classes. You learned how to store information in the class and how to write methods that give you classes the behavior they need. You learn to write init methods that create instances from your classes with exactly attributes you want. You saw how to modify the attributes of an instance directly and through modules. You learned that inheritance can simplify the creation of classes that are related to each other, and you learned to use instances of one class as attributes in another class to keep each class simple. You saw how storing classes in modules and importing classes you need into the file where they'll be used can keep your project organized. You started learning about the Python standard library, and you saw an example based on the ordered dictionary class from the collection modules. Finally, you learned to style your own classes using Python convention. So I hope you learned a lot about the object-oriented programming and importing classes and styling and standard library. Now the main thing is doing the practice. Do practice, find problems to solve, and that will make you able enough to implement real-world problems into the Python, such as controlling a robot and animating different projects and so on. And yeah, that's it from me from today's class. I'll see you in the next class where I'll be teaching you about creating projects, and I'll create at least 5 projects.